Let's look at another instantaneous rate of change problem. We have Tina's weight in pounds is given by, so similar to the example we looked at before, W of t equals 140 minus 1/12 t squared. By the way, if you haven't seen the lesson on average rate of change, make sure you watch that first before you watch instantaneous. So this is her weight t months after January 1st. How much weight is she losing per month on July 1st? So, this is an instantaneous rate of change problem because we are concerned with a particular day, all right, before we did her average weight loss over a year's time. Now we'll be doing instantaneous rate of change on July 1st. So again, that's going to involve the derivative of this equation. Again, here's our picture we drew before of her losing weight. We just want to know at a particular point in time how much is she losing at that time. And it will be per month because t is in months, right? And that's another thing to talk about. How do you know what your units are? Well, when you take the derivative, it'll be per month, right? And then this will be your y value. She'll be using she'll be losing so many pounds per month on that particular day. All right, so it's not how much she'll be losing per day. It'll be per month, even though it's on that day. Okay. Now you could figure out how much she's losing per day. I suppose you could find per month and divide that by 30, right? Be an estimate. But anyways, just letting you know, that's how you figure your units out. So W prime of t would be her weight loss per month, and July 1st would be our t value. So we need to figure that out, right? But the problem said it started at January 1st. Whoops, that's a previous example. So just need to figure out how many months go by from January 1st to July 1st. So it's 6 months actually. So t is going to be equal to 6. That's your step 3, determining your instantaneous value. Very important there. Now you want to determine your function, which they gave you, and then take the derivative of that. We know the derivative of a constant is 0. So this is w prime of t, taking the derivative. Then we'll use the power rule to move the 2 down, subtract 1 from the exponent. Here's our w prime of t equation. Pretty simple, negative 1/6t. So basically what this means is you plug in a t value. Let's say you plug in 12. That'd be 12 months, right? You'd get negative 2. So at 12 months, she's losing 2 pounds per month. Okay, so actually as time increases, she's losing more and more weight. But we are concerned with 6. Plug in the instantaneous value. After 6 months, she's losing 1 pound per month. This is kind of interesting because this was her average weight loss per month after 12 months. So right in the middle is her average. Pretty interesting. That must have something to do with the vertex of the parabola, I would think. Anyways, Tina is losing 1 pound per month on July 1st. Pretty simple, right? That's it. Again, if you were to plug in 12, she'd be losing 2 pounds per month, so on and so forth. That's it for this example, instantaneous rate of change problem. We're going to look at a few more for now. If you have any other questions about this, let me know.